Good afternoon or good morning. Welcome to the second session of the day on consciousness and evolution. We're very pleased to have two excellent speakers today. Our first speaker is Terrence Deacon from UC Berkeley, and I just lost my notes here. Okay. He's in the departments of anthropology and neuroscience at UC Berkeley. He trained at Harvard and got his PhD there and taught there for many years. He worked on, among other things, trans-species fetal neural transplantation. He's known for, among other things, two books, Symbolic Species, Evolution of Language, and Incomplete Nature, Origins of Life and Consciousness. He'll speak on dynamical origin of the self, other distinction at the core of conscious experience. Please welcome Terrence Deacon.
Well, thank you. This will be something entirely different from what you've been hearing about quantum theory. I'll say very little about that. Though I'm a neurobiologist by training, I'll also say relatively little about brains. I want to talk about a very simple model system that I think helps us think through some of these problems. And I want to begin by saying that I think we've been placed between a rock and a hard place in our discussion of consciousness and subjectivity. And I want to pull us out of that by backing off into something very much more simple. Because I'm worried that our focus, particularly on things like panpsychism or just simple computational reduction, puts us at extremes that don't make sense for us in lots of ways. And so what I want to present is a sort of third intermediate choice that's not quite so exotic as either of these. And I think part of our problem has been exacerbated by assumptions we've made about the nature of information. In many ways, information has lost its meaning in the last half century. And let me just read two quotes here, one from one of the founders of information theory, or what he called communication theory, Claude Shannon. He says, the fundamental problem of communication is that of reproducing at one point, either exactly or approximately, a message selected at another point. Although communications often have meaning, these semantic aspects of communication are irrelevant to the engineering problem. In other words, he's an engineer, not interested in what people were saying, but interested in basically how many bits can be passed through a channel in a certain period of time. Following up, one of the first people to really present information theory in a course at MIT, Robert Fano, has this to say in sort of reflection on this. He says, I didn't like the term information theory. Claude didn't like it either. You see, the term information theory suggests that it's a theory about information, but it's not. It's the transmission of information, not information. Lots of people didn't understand this. Information is always about something. It is information provided by something about something. And it's that aboutness that we're troubled by, because that's, of course, what minds are interested in. They want to find out what something is about. The result is we've been thrown into a tizzy struggling with sort of computational views, thinking that somehow if we put lots of information together, information just in terms of signals, forgetting what it's about or that it has to be interpreted, that somehow we're learning something about our own consciousness and about how the brain works. But we have to remember that in many ways, computation is just finding a way to map symbolic operations onto machine operations. And if you find a machine that operates in a way that you like, all you have to do is assign certain symbolic states to different states of the machine, and you can turn the machine over and run it, and it'll compute for you. It'll do computing. But of course, in this process, what we've left out is what it's about, what it refers to, and how it refers, how that's interpreted. And of course, that's really the problem of consciousness, the one we're struggling with. And of course, things are not just interpreted. There are some things that we ignore and other things that we don't because of significance as well. For information as we currently understand it, information as a signal property, intrinsic signal property, in effect, the value of it, the interpretation of it, the aboutness of it is assigned extrinsic to it. It's not something intrinsic. And that's the problem with computation. Now, we've become fascinated, and here, of course, there's a lot of talk about quantum physics. I'm not a quantum theorist. I'm a biologist by training. But I wanted to point out that there's a really useful and perhaps troubling correspondence between the Cartesian dualism and what I think is a kind of modern methodological dualism. And I think we're forced to this in part because of this computational view that suggests that mind is maybe just a machine of some sort. And to get out of it, I think we've looked for our answers elsewhere. And there's this nice correspondence between Descartes' res cogitans and his res extensa. The extensa world, the physical world of extended physical processes, is in effect mechanical. It's what the intrinsic properties of information as a signal property is about, effectively. He, of course, had to argue that the res cogitans, all of that stuff, the formal stuff, the experiential stuff, the logical stuff of the world, is somehow disembodied. It does not have extension in any clear sense or clear location. The problem he faced was, of course, how does it interact with the physical world? He came up with an interaction model in which he identified a structure in the brain. In fact, it's the only clearly unitary structure in a system that's mostly bilateral, the pineal body, that somehow this other realm works. Well, I think we do something similar with the quantum realm, and I think the reason that it's attractive is for exactly these reasons. Because in the quantum realm, also, there's a problem with spatial location. There's a problem with temporal location. There's a problem with the excluded middle issue. That is, they're sort of like res cogitans for Descartes. And so we're still struck with this issue. Now the problem then is, of course, something similar to Descartes' interaction problem, and it's basically today called oftentimes the measurement problem or the decoherence problem, and so on. The point I want to make is that this is attractive in part because it's dualistic. And I want to be clear that I think that's a potential danger for us. It's not that I think that quantum features are irrelevant. I think they're quite relevant to every physical process. I think indeterminacy has something to tell us maybe about some of the acausal features that may be relevant to issues of free will. The way that slight differences in initial conditions can be amplified and amplified into large-scale differences at a macroscopic level if the dynamics is right. Or superposition, which is this trouble with locality and non-locality. It may help us understand how potentials that are not yet realized might both coexist and be capable of being expressed. Or entanglement and spooky action at a distance might help us understand issues of binding in the nervous system, why there's a single experience of consciousness across vast numbers of neurons, and so on. It might even help us explain something like psi phenomenon, ideas about extra mental consciousness in various forms. The problem is that basically, none of these issues address the so-called hard problem that David Chalmers suggested. That is, that in effect, given any such process we look at in the physical world, it's conceptually coherent that it could be instantiated in the absence of experience. It follows that no mere account of the physical process will tell us why experience arises. The emergence of experience goes beyond what can be derived from physical theory. No amount of material explanation seems to provide an account of subjectivity. With each added datum, the question, why is there experience, can still be asked, without seeming to have reduced it any. I've often called this the Zeno's paradox of the mind. That is, we can get closer and closer to something and not seem to cross the threshold. I think this is why lots of the theories that we've heard here, though I've not been here to hear many of them, And theories that involve quantum consciousness issues and information integration theories and so on oftentimes end up appealing to panpsychism, in part because they believe, they buy the argument that it can't have a physical explanation, that somehow consciousness defies physicality. And that as a result, we have to, in effect, give it up. We have to assume that it's a fundamental property of the physical world, as Max Tegmark at one point suggested. This kind of panpsychist perspective, or pan-experientialism, or pan-subjectivism, there's lots of ways to frame it, is unfortunately a kind of non-explanation. It says it's outside of science. Yes, we can do a lot of other things. We can deal with the binding problem and so on, but maybe this is outside of science. Now, that's very attractive if you have this sort of mystical yearning of the world, but if you're a scientist, it basically says you can't touch it. I want to suggest that maybe we try to bite off too much. Because we tried to answer Descartes' problem, this distinction between mind and machine, so to speak. And Howard Pettit calls this locating the epistemic cut, where it is that you have to think about representations and knowledge and information in the world, in the sense of information that's about something. On the opposite end of things, we have the deep panpsychist view. I think it's also captured here by John Archibald Wheeler in his claim that the universe is just it from bit, that everything has a little bit of something like consciousness in it. There's people in the middle, and I stand in the middle. And I think the epistemic cut needs to be made between life and chemistry, living and non-living chemistry, so to speak. So what I want to do is I want to start really small. I don't want to tackle the consciousness problem to begin with. I'll try to get there before I end today. But what I want to do is to say, let's not deal with the mental self. It's too complicated, and to some extent, it forces us to assume a lot of things. Assume a lot of things about what we are. And assume that the sentience that's part of consciousness is somehow just given, and I have to take it into account and find some way to map it to the brain. That's a big, big order. So what we need to explain is the nature of sentience, I think, in a simpler way. In its first forms, because I think only when we can get to its simplest forms and how it's manifest in creatures that don't have brains, that are very, very simple, but still react to the world, still have identifications of what works and doesn't work, how to interact and how not to interact. Once we understand that, then we might have at least a chance to build our way up to understand the kind of sentience that maybe brains produce. Now, I think there's a useful way to start this, and that's to look at the difference between machines and organisms. Machines are functional. They produce functions. But the functions are not in the machines. They're not anything about the physics of the machine. The laws of the universe are working in the machine whether it functions or not, whether it's broken or functioning. And what we assume is that if at least you're not in a fully panpsychic realm, that somehow there's no one home in this kind of a machine. Here, this is an old printing press. And the function of the machine is therefore determined by constraints on the dynamical excursions that its parts can undergo. When those constraints are loosened, it loses its function. But the constraints are not identical to any machine components, and they're not identical to any of its physical properties. These constraints that cause function, that are the basis of function, are not there. They're coming from the outside. And so, if there's a major change in these constraints, the function goes away. Physics doesn't go away, the function goes away. I think that the problem of consciousness is a problem of function. So let's look at a simple organism. I'm going to go much, much simpler than this. For organisms, what we say is the functional constraints are imposed from the inside, unless you believe in intelligent design. And you're an evolutionary theorist like myself. You argue that somehow the functional constraints that keep organisms functioning are from the inside. Even the simplest organisms have something I think we could call simple self. We say they self-repair, they self-defend, they self-reproduce, and we're using self in a realistic sense. I think there's also a very simple sentience inside. That sentience is about how to interact with the world, how to know when to reproduce, how to know when repair is necessary, and so on and so forth. It doesn't necessarily have any mental components. But here's something important. Like the machine, these functional constraints are not physical features. They're not in the machine. They're not the parts. They're not part of the components, and they're not part of the physical features of it. The functional constraints, things that don't happen, that aren't allowed to happen, are not there precisely because they're not allowed to happen. But when they fail, when the constraints that keep me going fail, I'll die or I'll gain diseases. Degrees of freedom have been added, and as a result, the functions begin to degrade. It's this negative sense of function as constraints. Function is not what's there, but what's not there that I want to focus on. And I want to do it in a sort of hierarchical way. I've been working to develop a theory of dynamics that can build up to life. Not to something as complicated as you and I, perhaps, but just across that threshold into life. How do you do it? I've come to realize that it takes 3 steps, not 2. It's not something that chemistry just suddenly comes alive. In fact, what has to happen is there's got to be thermodynamic decay. The big story of the world is that it's breaking down, it's falling apart all the time. But that asymmetry turns out to be the driving force for all that's interesting in us. And I think we have to begin thinking about consciousness as a thermodynamic function. So let me tell you what I mean by that. The second law of thermodynamics is a regularization story, an irregularization story. Things get more and more irregular spontaneously over time. Any constraints, any order that's there, tends to dissipate over time, just like it does in you and I or in our machines as they run. But once in a while, you can pit thermodynamic processes against each other, and they will produce self-organized phenomena. I like to call them morphodynamic features. They're dynamic features that produce form and regularity. They're regularization processes. Things get more regular rather than less. And as a result, new constraints can get generated. New things, new dynamics can be held at bay, so to speak, and things get simpler and more organized. But what I want to argue is that, in fact, life isn't just working against the second law of thermodynamics like this. It's regulation. We have to regulate the process of regularization to produce life. Why? Because we have to preserve the constraints over time. That's the problem. Morphodynamic processes, you can call them self-organized processes, happen because we push something beyond equilibrium. This has now been known for half a century. Lots of features that we're familiar with, for everything from whirlpool formation to crystalline formation, and one of my favorites, the Rayleigh-Bernard convection, as you put a thin coat of oil in a heated pan, and you heat it beyond the level at which conduction of heat can dissipate the heat into the atmosphere, and special what we call roll cells form, and then eventually columns of moving liquid form, and they form nice, neat hexagons in the surface, interestingly enough. Regularization that's not intrinsic to oil, to hot oil, but it's intrinsic to close packing problems. And it's just simply because this organization of dynamics, of moving things around, is the most efficient way to dump the heat into the atmosphere. It's the most efficient way to undo what caused the process in the first place. Well, if life worked this way, it would be intrinsically self-undermining. If life was producing its order by dumping entropy into the world as fast as it possibly could to produce order, it would be destroying itself very, very rapidly, undermining itself completely. What has to happen is this has to be avoided. We have to use self-organizing processes to produce the order of living processes, but we need to then regulate them so they don't do this. So how does this regulation happen spontaneously? I'm going to suggest that it can happen spontaneously if you counterpose two morphodynamic processes with respect to each other. And I'm going to give you a simple thought experiment that's empirically testable that we've been playing with. First, a chemical process, sometimes called autocatalytic set processes or reciprocal catalysis, where a catalyst, a molecule that causes another chemical reaction to take place, like this over on the left, where it's breaking a molecule by virtue of its specific fit. If that process over here to the right produces instead another catalyst that causes another reaction that eventually produces the first catalyst, you get a kind of runaway process. And you can produce more and more catalysts. The process speeds up and speeds up and speeds up. But in the process, uses up all the substrates in the area and eventually will come to a stop. There's another self-organizing process that I find is quite interesting. Both of these are widespread in living organisms. This one is called self-assembly. The surfaces of viruses are formed not by having complicated processes to assemble them. You have molecules that have three-dimensional shapes and charges that just tend to stick to each other and fall together in regular patterns. And as a result, the virus can be really stupid, so to speak. Invade your cell, produce lots of these molecules, and they will just form around the RNA or DNA that the virus has also replicated. Cell surfaces are formed this way. Microtubules, which I'm sure many of you heard about lots of times, are also formed this way. They're self-assembling processes. And they're controlled by lots of processes, possibly even, as I'm sure you know, quantum processes that may play a role in speeding up or slowing them down. They play a significant role in changing the structure of cells, of giving cells stability, and also can form sort of roadways in the cell for molecules to sort of ride upon. Here I show in the bottom right how many microtubules are in a particular cell here, a neuron, and you can see vastly numbers of these cells here labeled with a fluorescent label. The interesting thing is that these two processes have an interesting relationship to each other, which I've tried to capture here by the matching red and blue statements here. Because molecular reciprocal catalysis produces high local asymmetric concentrations of a small number of molecular species. But this is precisely what's required for self-assembly. Self-assembly is like crystal formation. As the surrounding material is absorbed into the crystal, the concentration goes down, and eventually it reaches equilibrium, and the process stops. But if you want to grow something to completion, you need to keep adding stuff to it. Well, it turns out that reciprocal catalysis can add new molecules in a local area very, very rapidly and keep up with the process that they get taken out in the building of something like a viral shell. On the other hand, the problem with catalysis that's dependent on other catalysts is that over time they diffuse away from each other. And if they can't interact, of course, you won't have this process running. So the problem for them is diffusion. But here's the nice, neat thing. An encapsulation, like a viral capsule, can actually stop molecules from diffusing. It also, of course, stops the chemistry. So what we've been playing with is a simple, and today I'll talk about it as a thought experiment. It's something that's empirically testable, and we're struggling to get this done, in which basically you have up here on the far right, you have a circle of reactions. This is reciprocal catalysis. C and F are catalysts. Raw materials A and B and D and E here. These are operations that can go in both directions. A catalyst speeded up in one direction. But if in addition, one of these processes also produces a side product, a molecule that's just sort of a waste product that's popped off to the side that happens to self-assemble, like the capsule of a virus, then what will happen is that capsule will tend to form in the very region where the most rapid catalysis is going on. And that means if it forms quickly enough, it will enclose the very catalysts that produce this core. Now, when it does so, whether it's in a tube or a polyhedron like this, like a viral capsule, these are both kind of things that we find in viruses. This is a model based upon viruses, in fact. What we will find under these circumstances is the catalysis will stop. But the issue is that if it's broken open somehow by some chemical or heat process, then it releases the very catalysts that will produce more catalysts and will produce more containment. In a sense, it will repair itself. It'll put itself back together. In fact, even if it's broken more than this, the process will still persist, and maybe you'll get 2 or 3 produced. This all depends upon the environment being right. Well, let me just talk about this. It's a kind of work cycle in which you've got one process that needs substrates and energy, and another process that needs to have components continually produced. They produce a little bit of entropy, because they're both self-organizing processes. They're going rapidly. They're using up their raw materials rapidly, but they each correspond to each other in a way that's self-stopping. And by self-stopping, they now act as a sort of ratchet. They don't allow that relationship between the parts to degrade. By doing so, they stabilize a constraint. They generate a constraint and stabilize it. This is now not just regularization, it's regulation. Now, you might think that what I'm talking about has nothing to do with any of this consciousness stuff. The rest of this, I want to show how it might have something to do with it. Because if you think about it, each of these are producing what amount to boundary conditions for the other. Both they make it possible for the other to exist, and they keep the other from degrading and falling apart. As a result, what's interesting about this is that there is a higher order constraint here. That by virtue of their interdependence, their synergy on each other, they also maintain the synergy between themselves. They keep each other together in this process. And this is a sort of a higher order constraint. And what I want to show you is it's a formal constraint, an absence that is neither physical nor chemical, but a formal relationship, a synergy relationship. And this is important because it means that it can be pushed along, transmitted from substrate to substrate to substrate. And it can do other things as well. So here's another way to look at this relationship. Here we see this cycle of catalysts and the cycle of catalysts producing one constraint and self-assembly producing another constraint. They reciprocally hold each other together. I call this a teleodynamic work cycle. It's a dynamics that has an end-directedness. That is, it's directed to preserving itself. It's a kind of ratchet. If it generates constraints, it won't allow them to fall apart. But notice that if it's broken apart, the synergy constraint doesn't disappear because it's there in the relationship between all these components. And so it will regulate a process of repairing itself again. There's extrinsic material needed for it, extrinsic energy needed for it. Disruption is something that goes on, but also just simply thermodynamic decay is sort of held at bay in this process. I happen to think that this is how life begins, but that's not what I want to talk about today. What I want to say is I want you to focus not on the process itself, but on that higher order constraint that was generated by that synergy. Because what we see is that when the integrity of the system is disrupted, it repairs itself, but it repairs itself with new stuff, new energy and new material. So over a series of stages like this, what you can see is that eventually all of the material and all of the energy will be replaced entirely. The only thing that will hold that sequence together is this synergy relation, is this constraint, is this prevention of losing that constraint. That is something that does not have clear extension in space and time. It's a formal relation, and yet it's necessarily bound to this physical process. That's the only thing that's preserved. And what I want to argue is that's what we've been calling information in life. It's a constraint. It's something that's prevented from happening, that can be transmitted and maintained on lots of different substrates. So what I want to say is this is what produces the self that we talk about in terms of life: self-reproduction, self-repair, and so on. It's a second-order constraint. It's not a physical or chemical constraint. It's a logical constraint in some ways, a formal constraint. And it remains unchanged despite all these changes of materials and even dynamics, which is the reason that evolution is possible, because new kinds of materials that might do it better can be caught up in this process. It's multiply realizable. That is, it can be in all these different forms. And it maintains identity across all of these material forms. It's the information. But it's also the basis of something more important for us. It's the basis of the self-other distinction. In physics, when we describe a system and we want to describe how it's interacting with its environment, we arbitrarily bound it. Even when we struggle with abstract notions like integrated information, we have to define a system and it's bound. And we do so typically by differential strength and weakness, for example, of connectivity, or a variety of other ways that we do so. The point is that in living systems, or even in this simple system I call an autogenic system, the constraints that are maintained are what define the self-other boundary. The self-other distinction is defined by something formal, not something chemical or material or energetic. And that's what's preserved. We call it information. I think it's also the basis of the simplest forms of sentience on the planet. The capacity of a self-generative, self-maintaining, self-repairing system, like the one I just described, to respond to extrinsic conditions in a way that differentially modulates its dynamical organization, to minimize disruptive perturbations, and to utilize supportive conditions relevant for its persistence. Even the simplest bacterium does this. The most basic form of sentience, as I want to call it here, having a self and an other distinction, representing the other and distinguishing what aspects of the other, the non-self, are going to be relevant for persistence. I want to call this vegetative sentience. I think plants exhibit it. I think bacteria exhibit it. I think single-cell organisms exhibit it. I think most of the cells in your body exhibit it. And in many ways, a lot of the physiology of our bodies do it. But I'm going to suggest now that vegetative sentience is not associated with any subjective state. There's nobody home still. And yet there's a self, and there's a self-other distinction, and there's a response with respect to that self-other distinction. And I want to argue, however, now that higher forms that I will call subjective sentience actually supervene on vegetative sentience. In other words, what I'm trying to do is to decompose what we've been calling consciousness into something simpler, into something that makes simple biological sense, but it's not something that fits nice and neatly into res extensa. Imagine to take one of these same kind of entities and assume that its surface is sensitive to substrates, so that substrates that bind to the surface make it weaker and weaker and weaker over time, in which case it gets more likely to break open under these circumstances. But if this is true, then the surface integrity gets weakened in a way that corresponds to an environment that's valuable. This is not any special magical chemistry, but what this means is that dissociation of the whole is going to be more likely in a reproductively supportive environment. This, I think, is vegetative sentience. The system is responding, again, a simple chemical kind of process, responding in a way that recognizes what's good for it and not so good for it in the world. And it responds, it changes its dynamics appropriately. That's what I want to call the simplest form of vegetative sentience. it's a kind of representation as a result. Its internal dynamics represents its world, and it represents its world with respect to its needs, its future, its telos, its purpose, so to speak. Because it can represent something extrinsic, that thing that it represents is not actually inside of it. It's something on the outside, it's other. It's the self representing the other. This is that self-other distinction. And I call this the minimal vegetative sentience. Of course, it gets much more complex in other organisms. What's happening here is it's providing what amounts to an index. The number of bound substrates on the surface is an index of the environment and its supportive conditions. It becomes information about that environment for this dynamic, for this constraint. And it's being interpreted by this process. What I want to say very quickly now is this might have something to tell us about us and about how brains work. But it requires us to begin thinking about neural processes in dynamical terms, not computational terms. Because if dynamical processes in the nervous system can also link morphodynamic processes together, that is, self-organizing neural dynamics, so that they also support each other in this way, then in effect we have a kind of vegetative sentience. The point I want to make about this is that, of course, brains are parts of a larger system, a larger teleodynamic system, a larger sentient system. Our bodies have vegetative sentience as well. But now we have a system that's vegetatively sentient of the vegetative sentience that it's contained in. It's a second-order vegetative sentience of vegetative sentience, so to speak. And what I want to argue is that this is the basis of subjective sentience. Neural vegetative sentience of the somatic vegetative sentience, of which it's a component part. Because the body is an environment to the brain, even though the brain is a part of it. And so it's a sort of a part-whole relation. Let me just end by saying a couple of features about brains themselves, and I'll just stop at this point. One of the things we notice about brains is that they have things like emotions, and we'll hear a little bit about emotions in a minute. One of the things that's interesting about the emotional centers of the brain, if you begin to think about it in dynamical terms, those structures in the brain that we typically associate with emotions, like the amygdala and the nucleus accumbens, their major inputs come from all over the cerebral cortex. And they seem to make assessments about the valence of that input. Is it good for me or bad for me? That information is sent down to the midbrain and brainstem to a bunch of monoaminergic systems, which then send their projections all over the cerebral cortex and other areas in the forebrain, and they adjust metabolism, either the metabolism of neurons or even adjusting blood flow. This is what you would expect if the metabolism is like the thermodynamics that drives a morphodynamic process to regularity. And that morphodynamic process then adjusts the metabolism. And you get a complicated circle, a complicated within the brain teleodynamic process, autogenic-like process. I think that this helps explain a lot of the way brains work and why there might be something that we might call subjective sentience. Thank you.
That's great. Thank you. Just stay up for a second. Let's ask Catherine to come up and get ready while we take one or two questions for Terence, please. Right here.
Thank you very much. Could you please bring back the slide of the frying pan? If not, no problem. I love your interpretation of the frying pan. Now, why do you object to the idea that we are all the frying pans? Because I understand that your approach to teleodynamics seems to be objecting to the second law of thermodynamics, and we are going to be some kind of an exception to that.
Not at all.
Isn't this a
It's
simpler
driven by the
explanation?
second law.
It's not. So we are actually increasing entropy.
Yes,
just
we're
like the frying
increasing
pans.
global entropy, you and I. Locally, we're not. Locally, we've maintained a low entropy state. When we die, of course, our body will increase in its entropy for the first time in a long time. So it's not contra the second law. In fact, it's driven by the second law.
One over there.
Thank you for a wonderful lecture. You're saying that nervous system is a second-order sentient process. I was just wondering if you can extend this analogy to maybe a third-order process.
Absolutely. It's a great question. What I've tried to do is to lay out what might be a dynamical model where we can talk about the creation of a self-other relationship and how information is incorporated into that. My prediction would be whenever we can see that dynamics forming, whether it's on the internet, whether it's in a corporation, whether it's in a whole population of human beings, wherever we see that, we're going to begin to see all of these properties emerging at that level distinctly. That means that there's no upper level, no upper bound to this process. It doesn't mean that that's happening now, but it gives us, I think, a tool to look for it for the first time.
Okay, we better move on. Thank you very much. What's the title of your talk? On Consciousness, Life, New Emotional Body?
That's it's called Emotion and the Nature of Consciousness.
All right, our next speaker, Catherine Peel, Harvard Divinity School, Northeastern University, an emotion theorist who'll speak on emotion and the nature of consciousness. Catherine.
Thank you. Thank you so much for coming, and Stuart, for this fabulous opportunity to share my ideas among such a brilliant cohort. So today, I've got two things that I want to do. I want to offer you some new biologically informed information about emotion, a whole new view, one that challenges most of what we think we know about our everyday feelings. Feelings, pleasant feelings like joy, trust, love, painful feelings like sadness, anger, that I would bet we all have, zombies or not. My second goal is to point toward what this new view of emotion, this new biology of emotion might mean for consciousness. But first, I have to tell you a joke. What's this? Anybody remember from junior high? Yeah, a dead one of these, right? That's still my favorite joke because what's missing from this is the spark of life, that animating and guiding force that the violists used to call, say was necessary for life. Now, well, let me see here. Let me figure out my little device here. Oh. You got it? So while reductive materialism rejected any such idea, this new science of emotion suggests that the emotional system actually provides all of the functions that the supposed vital force was supposed to, at least, to giving rise to purposeful behavior, or at least what Nobel laureate Jacques Monod called teleonomic appearance of purposeful behavior. But emotional processes also point to something deeper or bigger, some other aspect of identity without which life wouldn't be possible. So I'm going to suggest that life isn't just this, but it's something more like this, like an essential energy circuit between two absolutely essential components with which life and consciousness would not be possible, certainly not our phenomenal experience. And I'm going to suggest that this is certainly part of the creative engine of the biosphere, if not speculatively, of course, part of the causal machinery of the universe itself. So I call this body of information the new emotional vitalism, for it offers a scientifically supportable way to conceptualize spirit as sort of this process and soul as whatever this other big thing might be, which I'm going to suggest is the fundamental capacity to observe. It puts a new spin on the whole monism, dualism debate, because you have that life over here can come and go. Something more like this implies a more ontological, enduring monism. Might be consciousness itself. So with all due respect to Terry, we're going to get crazy here. So my message is mostly echoing those that want to factor the subjective pole into objective sciences. Movements like endophysics, biosemiotics, and Andreas Weber's call to replace the old Enlightenment paradigm with one of enlivenment, where life and sentience and phenomenal experience are center stage. I add that understanding the biological function of emotion is a first and necessary step in that direction, and it will turn on a new appreciation of the word sentience. Now, Terry just helped me out here by setting the foundational mechanics here. So let's sort of keep that on this side, and we're talking about that, and then setting aside consciousness for another area without the nuances. So my foundational claim is this: by virtue of this vital relationship, all living beings are subjectively sentient. They're endowed with what Charles Peirce called the firstness of experience and what Antonio Damasio called the feeling of what is happening. This means that before there were brains, sensory organs, or anything like that, there first emerged a primal form of sentience that delivered two subjective gifts. Now this is where Terry and I diverge. A simple sense of self-awareness and some experience of good and bad evaluative feelings. I posit it to be the first variety of perceptual quality in the living system. So in this view, the answer to Thomas Nadel's question is that only a bat can know what it's like to be a bat, and in fact, any member of any species can only know what it's like to be that particular bat, or wombat, or spider, or human being. For whatever personal experience that might be, it is the universal feeling of something good or bad happening to me, what I call the hedonic self that I am. A little different than Terry's description. There's much more to say about the word hedonic, but biologically it captures the primal good or bad evaluative qualia that are born of deterministic physics and biochemistry, but then become legitimate cognitive representations even in the simplest living creatures. Representations that can build memories, guide optimal behavioral adaptation, the things that Terry talking about, higher order constraint. Now, I'm saying that this is in every living creature and it provides the directionality. So I realize these are some rather bold claims, and it's about to get worse. The word hedonism, if you will, or hedonic, implies that values do exist in nature, certainly at the biological level, and maybe deeper still. Now, this flies in the face of the time-honored policy of the naturalistic fallacy, but through this new lens, that looks to be a preemptive dogma, if not a tragic mistake. For the biovalues produced by hedonic qualia are universal to all living creatures. They're delivering messages about right and wrong states of biophysical balance, information about optimal physical conditions for life. They are also central to learning and development and evolution, and they ultimately undergird all of our moral and ethical discourse. Indeed, our emotional experiences, pleasure and pain, are the only biological tether to nature's value systems. And without a clear conceptual link to its ancient hedonic logic, all evaluative language, all words such as right, wrong, good, evil, are relative, if not misguided, social constructions. Unfortunately, this dogma has left emotion with a really bad reputation. It's bad stuff. Certain philosophical traditions pit animal emotion, lower animal emotion, with higher rational capacities and all that. And most spiritual traditions associate emotion with deficiency, spiritual deficiency, that gap between man and God. For example, here are the first two pictures that come up in a Google search for the word hedonism. We've got the first two of the 7 deadly sins, lust and gluttony. Now, objectively, all 7 of those deadly sins concern excesses in pursuing pleasure and avoiding pain. And some are explicitly emotions: pride, envy, greed, and wrathful anger. Worse, emotions also associated with deficiency in mental health. Most of the behavioral disorders, the DSM-5, the diagnostic canon for psychiatry, are also characterized by uncontrollable expressions in pleasure and pain, as well, and this is important, as distorted perceptions of time, space, and self-identity. In short, with science having dropped the ball on values, we've been blaming the messenger while missing its fundamental and biological message, which is almost exactly the opposite. For emotion also lies at the center of all human virtue, cultivating good feelings like trust, courage, gratitude, faith, compassion, and love, as well as the cooperative, kind, and caring behaviors they inspire, constitutes the spiritual wisdom, the common strand across all of our faith traditions. It's the wisdom of the heart, if you will. Biologically, they are the naturally divine benefits of our emotional vitality. A preponderance of these good feelings in daily experience also connotes optimal mental health, psychosocial flourishing, and emotional intelligence. Best of all, they are biomarkers for optimal physical development, immunity, and vibrant health. They signal this, that we've achieved that strong, coherent connection, letting us know that as our true north messengers, that we've hit upon the right states of being and becoming. So I point all this out at the beginning just to show you how far off base we are as it concerns emotion. It's conspicuously missing from most hard science models. It's so broad and complex that even psychologists can't agree on a definition, let alone a function. So my hope is that we can set aside what we think we know about emotion, start over with a clean slate, and trust your own experiences, your emotional experiences, and your spiritual experiences to evaluate what I'm offering you today. Our task will be to learn what positive and negative emotion mean, how they work together, and what they're telling us about this. So, I'm going to really quickly go through what is emotion, what is its function, which I'll tell you right now is self-regulation. The very stuff Terry was talking about, but that it tells us in very clear hedonic terms exactly what to do and when. Thankfully, a lot of speakers have covered a lot of this territory, so I can focus in on what's new. First, then we'll talk about how these regulatory doings are rooted in self-organizing happenings, the laws and forces of thermodynamics. Thank you, Terry. But throughout this discussion, we'll discover that the self is kind of a multidimensional concept, including the body, the mind, and something more abstract, like a Kantian fractal whole. So the key idea, of course, is that emotion is a sense, an entire sensory system that its distinguishing feature is, of course, the good and bad categories of qualia. Psychologists call this affect, and Joseph Ledoux offered an elegant contrast between cognitive computations, regular thoughts that lead to other thoughts, and affective computations, which are generated by self-relevant stimulus, and they lead to action. But when we dig deeper into the biology, we'll notice that affective computation emerged long before brains. So I'm suggesting that emotion is the grandfather of all other senses. It's ancient evaluative logic still encoded within visual aesthetics, acoustic resonance and dissonance, and pleasant and unpleasant aromas, and warm, fuzzy, cold, prickly experiences of touch. This becomes apparent when we reduce it to its two components. We've got the binary feelings that trigger hedonic actions to approach or avoid but whatever's in the environment at the moment. We talked a little bit about that. So it is the good for me, bad for me pattern of behavior that we see of approaching that, which is good for me, and avoid. So, but what I want to point out is that the guidance within it, that's the animation and guidance that we see, but the guidance includes all forms of learning. And Ivan Pavlov demonstrated, hedonic behavior is the foundation of classical conditioning. The feelings and their coupled approach and avoid behaviors are the hardwired, unconditioned stimulus pair upon which almost any sensory stimulus can be remembered as good or bad. And the function, as we said, was self-regulation, and that's why it's self-relevant material. It's about regulating the self. And now, it may have started out with very modest hedonic beginnings, but it's now fully loaded, ranging from autopoietic self-making, self-preservation, genetic self-replication, epigenetic self-development, self-determinism, all this, even including the mindful self-control and self-transcendence of contemplative practice and spiritual experience. And in fact, the evolution of the emotional sense is reflected in the triune brain structure. It's also noted in human developmental processes with hedonic affect inherited at birth. Basic emotions, sadness, joy, anger, fear, disgust, emerging over the first 3 to 6 months. And the complex blends and shades are forged by personal experience and specific sociocultural context. So in a nutshell, we have our emotional vitalism provides a sensory palette with 3 different levels of self-regulatory information. Informative feelings we can tap to choose the right responses in virtually any situation, ultimately to attain and maintain the biophysically right states of being and becoming. But it all starts with understanding the fundamental bio-evaluative messages of pleasure and pain. So if we begin with the brain, we see that it's everywhere. There are 2 bidirectional circuits, at least, and it means that it not only it concerns sensory stimulus here, but there's a bottom-up path from the body as well. As Antonio Damasio suggests, emotional feelings are somatic markers, messages concerning the body's well-being and its proto-self-awareness. So the self-relevance sensory system concerns the person's immediate physical environment, mental environment, and social cultural environment as well. But the self-relevance runs deeper still, concerning the identity of the body at the cellular level, playing out in epigenetic, genetic, and immune regulatory signals. Candace Pert noted the intimate connection between emotion and the self versus not self distinction of the immune system, positing that the peptides via the ligand lock and key receptor system, the molecules of emotion. As she put it, peptides serve to weave the body's organs and systems into a single web that reacts to both internal and external environments, changes with complex, subtly orchestrated response. Peptides are the sheet music containing the notes, phrases, and rhythms that allow the orchestra, your body, to play and as one integrated entity, and the tones and rhythms emerge in your consciousness as feelings and emotions. These chemical signals are also central players in epigenetic regulation, the new layer of genetic activity in the once what was presumed to be junk DNA. Now, many of us heard about this from Rudy and Deepak the other night, but for those of you that missed it, epigenetic regulation evidences a more Lamarckian form of evolution, operating in real time, yielding non-random variations in behavior and inheritance systems, variations that are heavily dependent on environmental context and personal experience. Epigenetic regulation utilizes also methylation and acetylation markers on histones, which are critical components of the ancient innate immune system, mediating responses to environmental stressors. The key evolutionary point here is that in early life forms, the functional mechanisms of adaptive immunity and sensory motor control were one and the same. So our bad feelings, in fact, are the body's distress signals to self-relevant environmental stressors, but so are our good feelings. For originally, Hans Selye, who coined the term, there were 2 kinds of stress. There was also eustress signals for the beneficial kinds of environmental stressors, energetic resources, novel opportunities, social relationships, all the good stuff that creatures need, desire, and pursue to maintain life. They're also captured by Gibson's ecological affordances, those that underlie perceptual learning and development in his model. Had this functional biological connection been made between Selye's medical stress model and Gibson's ecological and Pavlov's learning model, the information sensory nature of emotion might not have remained so opaque. In fact, the term cognitive dissonance might have been more accurately called emotional dissonance, because that's what it is. So, this is likely what Lamarck meant when he talked about how animals had felt needs, subjective feelings that drove behaviors, played a role in evolution. And in fact, much higher up the evolutionary ladder, which is a whole different talk, there are the needs, like something akin to Maslow's needs hierarchy, are indeed encoded in the appraisal themes of our basic and complex emotions, the other 2 levels that I was telling you about. So to my mind, Lamarck deserves a whole lot more credit than he did for his prescience about the role of experience in personal behavior and evolution. And even the neo-Darwinians should be singing his praises, because this innate hedonic logic also provides an internal bottom-up reflection of subjective reflection of external top-down criteria for natural selection. So what we have here, Herein lies the innate purpose, the genuine telos encoded in our selfish genome, although it's more self-regulating genome. The ultimate evolutionary meaning of pleasure and pain are these two what I call self-regulatory purposes. The natural punishment of pain serves the non-negotiable impairment of self-preservation of the body, which is what Darwin talked about survival, asking us to reduce or avoid those particular environmental conditions. The innate rewards of pleasure concern self-development of the mind, completely left out of the model, but very, very important for our purposes because it feels good. So Darwin and genetic regulation are to body, like Lamarck and epigenetic regulation are to mind. And with the signal chemistry, the implication is even a single cell has a mind. So this view jives really well with the 4 E's view of cognition put forth by Maturana and Varela, that mind is fundamentally embodied, grounded in physical material, enacted through an ongoing process, embedded within and inseparable from its environment, and extended via development and personal experience. But of course, this new science adds a 5th E, identifying the evaluative component. So to reconcile this view with Cartesian dualism, both his mind stuff and body stuff are over here in the body mind, nothing left. So how it works is like this. There's a 3-step thermostatic loop of mind, very much like your home heater. And this is a zoom in on the sensory motor system of the E. coli bacterium. That's perfect hedonic behavior that are mediated by this little loop of mind. So there's a fundamental self, not self-comparison, being made. There's a signal whenever imbalances are, which is the emotion I'm arguing, and they trigger a self-corrective response, behavioral response, which approacher avoids. It's actually a little cybernetic loop, likened to the thermostat, like I said. So as Terry suggested, this thermostat metaphor is not really a metaphor in terms of the underlying physics, because it's all about energy conservation and avoiding an entropic an entropic destiny. So Terry says there's an arrow from thermodynamics to morphodynamics and teleodynamics. And when we examine the chemical machinery of the E. coli, we can see how nature has also forged an arrow from favored states and favored shapes to favored experiences. So far, Terry and I are in agreement about the chemistry here and how it plays out, and I don't have really a lot of time to explain it. So this is a picture of the cell membrane, and it's wonderful. It goes all the way through. You got little outside feelers that collect stimulus and inside tails that carry out chemical signaling and other things. And what happens is there are 2 processes that whenever there's good or bad stuff, there's a phosphorylation on the inside tails of the receptor complex that leads directly to a switch in the flagella motor of the little tail that sends our little creature up the stream. So if it's counterclockwise, the creature goes forward, and if it's the other way, the creature does a little tumble and turns back. So it's an elegant little hedonic device here. But the second signaling system is really cool, and this is where the connection to physical health lies. The second system, also going on down here, at the same time, carries meaning at on a longer time scale, and it provides literally a record of when this was increasing, it was good for me. When the methylation was decreasing, it was bad for me. So that ultimately provides a record, an adaptive immune memory of these things. So it establishes evaluative categories through which trial and error learning then occurs. But underneath all of this is a digital relationship between positive and negative feedback processes. We've heard a lot about that. I don't have to go into it. But fundamentally, positive feedback concerns change, whether it's destructive or constructive, and negative feedback concerns preserving stability and maintaining balance points. So there's where you get your regulation. But underlying that, it might be something like, actually, I think it is, the edge of chaos criticality that balances systems, keeps them poised on the edge of chaos between too much stability and too much disorder. Wherein is according to Chris Langton, one of the people who coined the term, the information processing can occur. So there is a computational thing here. In fact, Stephen Wolfram suggests that this was a universal computation within all pattern formation. We heard about this a little bit from Celine the other day, and it's the same oscillatory behavior of standing waves that undergird the self-organizing dynamics she talked about, as well as honor bonds, clocks within clocks within clocks view of information. So I point this out. This slide is our signaling receptome. It's the entire tree, goes all the way down to the most ancient receptor complexes. These guys, basically the sensory organs of the cell, and where we find the 7TM transmembrane receptor, that picks up electromagnetic fields, simple ions, lipids, amino acid peptides, the molecules of emotion, and most of all, one of its main functions is to establish biological clocks, so biorhythms, again, clocks all the way down. So, but what we're really, it's an elegant piece of biophysical machinery, just like Terry says, and we agree on all that, but we're still confronted with the hard problem of consciousness. And I believe that the step one comparison between self and not self requires a fundamental capacity of observation or consciousness. Fortunately, our hero Stuart comes to the rescue, and he offers how the comparison can happen through quantum superpositions in the fabric of space-time with a self-collapse into one actual event that occurs with flashes of consciousness and emotion. So that's really cool. And actually what he's offering is what's going on inside the cell that's created by Candace's molecules of emotion. So it's no surprise to me that they both use a music metaphor. And of course, Audubon's singing microtubules are part of this music too. And this is probably the best science can do because it is an objective reduction. There's no subject in the story. There's no self, which I still think we need for this. So I'm not afraid to conjecture a little bit. I'm a bit of a fallen scientist, but I believe that our experiences are really central to everything we do. So enter Stu Kaufman, who offers at this point a full-on quantum version of criticality with his poised realm model we'll hear about tomorrow. But essentially, there's an ongoing engine between a realm of ontologically real possibles and a realm of ontologically real actuals, the classical realm, quantum realm, and it's mediated by mind. So he gives us subjectivity. And at the edge of chaos dynamics that we see all the way up actually starts here. But now that might be, all we need for this. Very cool, lots of good places to stop. But I still think we need to be concerned about the self. Its relativity, its individuality, its fractal multiplicity, and its personal self-relevance. So throughout the story, the self is actually functioning as a part and a whole in these ensemble dynamics we're talking about. We're talking about network nodes that give rise to, so there's boundary conditions that can be changed by the connectivity of the nodes, and so there's a holistic sense of self with the network itself, and then an individual sense of self at the node level. So if we think about this in terms of a panpsychist view, we find ourselves like in a land of Leibnizian monads with sentience, which he also said had desire, or Whiteheadian pretensions with the actual occasions of experience that also have feelings. We also find ourselves in Deepak's territory with the idea of Indra's web. Each node is shimmering with consciousness. And while we have not privileged the brain, we have privileged emotion. Because I'm suggesting that if there's subjectivity in these nodes, they in fact are tuning their own boundary conditions by adjusting their own connectivity, and it might involve entanglement processes or whatever, but I think that there is a preference in this system that we see of binary switching, and that it might very well be our true north beacon of, actually, so when we're over here now in the realm of the quantum and whatever this might be, there's no need anymore for self-preservation because the physics totally takes care of form all by itself. So there's only one imperative left, and it's the self-developmental imperative that we experience as positive emotion. So if we want to suggest that it might go further down, that is a more primal imperative than self-preservation of form. So it might mean that when there's no body to defend anymore, there might be an ultimate state of bliss. as many mystics have told us. So we've been toying with the idea, the rather ironic idea of quantum hedonism in the universe, with an impulse of pure desire to creatively expand and complexify, but it's an open-ended evolutionary trajectory, like what Teilhard de Desjardins' omega point, but it's never ceasing. And in fact, its elegant mathematical precision contains what Gregory Chaitin calls pure crystals of creativity. This implies, of course, that our preferences, desires, and choices, through this perhaps interactive mechanism that Stu suggested, are giving us a really active participatory role in the universe. So that suggests that self-regulation is not only rooted in self-organization, but it's rooted in some deep sense, literal sense of self-actualization of matter itself. So I'm suggesting that over here on this side, when we see a self comparison here, it's actually fundamentally a self not yet self comparison against whatever our potentials may be in this realm of the possible. And they probably wrap into our genetic potentials over here, but I want to call them soul potentials, whatever they may be. And that this fundamental self not self comparison, together with a not yet self comparison, explains our emotional dynamics. So I want to suggest that that's really what's going on here. Now, if we take that back to the land of the living, the soul, even if it's beautifully driven like this, it shows up as a social mind culturally. We have both an autonomous and a communitarian aspect of our identity, not just us, but every living system. So when we notice that the autonomy is our sense of preserving the body and is usually supported by negative emotions, and our sense of community, which is about self-development, is more about the positive emotions. We can see dynamic patterns all across the evolutionary ladder of animals behaving with both an autonomous and a social behavioral regime. We can see facial expressions, nonverbal postures, clearly observable behaviors across the animal kingdom that suggest emotional sentience is very real and that it does in fact mediate two aspects of the self, which I say are the not yet self possibles interacting with the mind-body. So I want to, you don't have much time, and I'm going to give a really quick tour through what this looks like in nature, and I want you to think for yourself if this is just a chemical machine or if there's genuine sentience going on, and if something deeper might be going on. So the very first thing we see, even in our little E. coli bacterium, we see quorum sensing, which shows how both an autonomous identity and a communitarian identity, and I'll spare you the details, but they use the same peptide signaling systems as the hedonic mechanism to identify self and other in the environment. And they can get together and ball up against antibiotics, or they can engage in virulent assaults against other species. We see, of course, our famous slide mold, who can be both an individual and a communal self, depending on environmental circumstances. We see social behavior all through insects and kin recognition. And of course, insects have brains, so we're already starting to complexify. Then we come to the reptilian limbic system, which is arguably the source of the basic emotions. You see a cooperation through territorial behavior and hierarchy, as well as aggression. We see attachment. In fact, attachment is central to our sensitivity to the environment and our epigenetic processes. We see play, we see care, we see morality. Animals get very upset if you don't play fair. There's lots to say about that. We see mammalian altruism in alarm calls and bats having their own bat experience, sharing blood, and we see empathy in grief in primates. And we also see a division between whether the negative emotions are going to design the social structure or the positive emotions are going to design the social structure. The best one is the chimps and the bonobos, who the chimps are a little bit more angry-oriented, hierarchy, kill, 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 where the bonobos are all about let's make love, and they exchange sexual capital and have happiness for a much more egalitarian sort of society. And I just want to suggest that we also have the same kind of thing going on here. What do we preserve? What do we develop? And without making the distinction between preserving the body, we end up actually preserving ideologies of the mind, which is exactly what we're not supposed to do. And so I'll end with a few concluding thoughts here about emotional vitalism, both the hope and the challenge. I want to suggest that we are harnessing our vitalism holds tremendous promise, but we have a long way to go. There's misinformation about our emotional system shot through our cultures and our language. We linger in the territoriality and dominance hierarchies of our reptilian ancestors. We carve up the human family and defend ideological boundaries against the evil other, when to nature there is neither evil nor other. Our very biosphere is one self-system, and our emotional wisdom says that loud and clear. But not only have we been blaming the messenger and failing to optimally self-regulate, we have been using the punishment of pain, which, by the way, as individuals, we're supposed to reduce by creating new resources in the environment and all of those things, changing those external conditions. We have used it against one another in a system of punishment and reward to control the behavior of one another. And in doing so, we have created instead of reducing the distress signals, which is the prime fundamental commandment of nature, we have increased them several-fold. And this is why we have thank you. This is why we have so much distress in our environment, but it's an entirely man-made layer that we can remove. But to the degree that we have complex negative emotions running the show and manipulating one another, they're pointing directly to ideas that we have that are destructive, and we farm them out into the social environment. So it all starts here with understanding how to reduce these circumstances. And really all we end up with are the 5 basic negative emotions, which tell us what's going on in the immediate environment that we need to change. And the rest becomes more complex, positive experience, the kinds of things that are going to give us vibrant physical health and all of this great stuff. So I'll stop there, because I think I've got 33 seconds left, and say thank you all so much for coming. And there's so much more to say, but that's all I got to.
We have time for just a few questions. Terry, why don't you come up, and we'll take them for both.
This is going to be quite emotional for me, so please bear with me. Hi, Catherine. This is actually directed at you.
Oh, hi.
Hi.
Need my sunglasses.
My uncle, he served as a US Marine for most of his life, and he retired. He's now retired, and he suffers from extreme PTSD and is resistant to all conventional forms of medicine. And in my opinion, I feel like the government and conventional medicine has failed him. And about a year ago, I met Graham Hancock, and he put me on to the research done by MAPS using MDMA. And he met a guy who was a veteran, and he went on a pilot study using MDMA and is 100% cured, and he goes around the world lecturing about it. I did tons of research since, and about 6 months ago, I found out my uncle tried to commit suicide twice. And for a few weeks, I kept waking up in the middle of the night, feeling like I was having a heart attack, thinking about my uncle. And I went to the conference in January where Stuart invited me here, and a week after that, I had my first ayahuasca session, and it dragged me through hell. But I emerged from it having formed a pact with God that I will do everything in my power to get my uncle the best possible treatment. And I believe MAPS have the best possible treatment. And I contacted dozens of doctors all over the world. They put me in touch with Rick Doblin. Dr. Luna recommended him. Frederica recommended him. I spent time with them in Zurich after that conference. And we're flying him out to California next week to get him treatment.
That's amazing.
The question is, basically, I've had it a few times where I wake up in the middle of the night with feeling really bad pain in my heart, thinking about another loved one. I've never had that. My fiance left me for another guy whose dad was dying of cancer, and I never had that then. I was heartbroken, but
I hate to be rude, but
yeah, I've got a
come to
question
the
now.
point. There's a lot
I've
of people
got a
waiting.
question now. Okay, the question's now. Is it that I'm too emotional? Because I feel like I'm quantumly entangled with these people. I feel their pain. Or am I too emotional? Is it just that I'm too emotional, or?
No, you're sensitive. You are sensitive. And in fact, we're getting more and more sensitive all the time. That's why there are these epigenetic manifestations of sensitivity to context and increases in all kinds of things that might be directly related to the man-made layer of pain we've constructed. Mother ayahuasca is another reason why I think that this model is more, it speaks more to human experiences, including anomalous experiences such as those. And it really does resonate at a very deep level, something more like this. Thank you so much.
Please be brief and ask a question.
Yeah, I'm an advocate of the hedonistic imperative, basically the idea that we should isolate the biomolecular signatures of pure bliss and then express them in the brain. So what do you think about that? A world where we all experience gradients of bliss and no suffering at all?
Well, there's a distinction between suffering, which is an ongoing thing, I think, created by our cultural structures that misunderstand emotion. There will always be a place for immediate pain because we learn through trial and error feedback, and so we're never going to get rid of those emotions. Otherwise, it would be just like some virtual reality where you have nothing but bliss, and it's like a heroin trip or something. You know, life wouldn't be meaningful. Sorry, David.
First of all, thank you so much, Catherine. Thank you so much for that. Really inspiring. So, in a current world in which immense bad feeling conditions exist, extreme poverty, economic disparity, persistent war, environmental instability, etc., what would you say can be the most effective and practical application of emotional sentience to restore good feeling and stability, a more balanced,
It really starts
conscious
with
experience?
It starts with self-regulation. The idea that we are first and foremost responsible for our behavior and all of the manifestations that cascade from our behavior. Right now, we live in a blame and shame society.
Okay.
You know, it's up to a judge or a jury who's accountable for what. We blame Satan and we credit God for all the things that maybe we're creating ourselves.
Thank
so,
you.
That's a big question.
Thank you. Yeah, and
we all need to learn about our emotions. I think that's the first step.
All right, cool. Yeah, thank you so much.
Hello, guys. Thank you all, both of you, for it was amazing just to hear you. Well, I would like to ask a question for both of you, actually. Would like to hear a little bit more. Do you guys think that is there a limit for self-development in a way of our own reality right now? Are we self-developing forever? And do you guys think that could be, what is the relation of this self-development with death in that dimension?
No, see, that's a really interesting question. And again, that's why I think that the business of the embodied mind, the chemical machine, that this isn't the whole story. I see so much beautiful balancing in the universe that I'm inclined toward reincarnation, and that this over here is actually maybe the collection of our experiences, and that's informing the not yet self. And we don't need to know about any of it. We just need to listen to our emotions and trust them.
You have a comment, Terrence? Thank you.
Okay. This is going to be fairly short. A long time ago, I myself was pondering the nature of pain. And I came to the conclusion it was very similar to dissonant music. Now, people actually physically feel pain when they hear dissonant music. Some people, anyway. Yep. You eventually become a little adapted to it. But so I think
feel it with most rap, other than Bobby, of course.
I'm wondering, you know, I'm asking you how related that is to, for instance, Annerbond's ideas, because that's clocks within clocks within clocks, but music within music within music.
Well, if there's clocks within clocks within clocks all the way down, and it's a new form of information, sort of like he's describing.
Okay. These last two questions there, and then there. Thank you.
Okay, I have a question on Terence. In the beginning of your talk, you said that panpsychist view is too extremist. And unfortunately, when you were going through your talk, it actually seemed to me that it extremely well fit the bill of the model you have presented. Can you tell us what's so different about these higher order, like sentience, which is not present in the, let's say, first order? Or what is so different there that you think that the panpsychist view cannot explain that?
It's a good question. Now, the main approach that I take is to make it as simple as possible. So one of the things I want to do is to not make a lot of assumptions, as simple as possible. And as a biologist, of course, I look to simple life for that purpose. Brains are as complicated as they can get, of course, and that makes it difficult. I'm actually talking about any brain. The argument I make is that sentience by itself, in a simple biological sense, looks very mundane. It's not, however, just thermostatic activity. A thermostat just regulates something besides itself. A living organism regulates its own existence, so to speak, and that makes it fundamentally different, all the way down to even the simplest system I described. I described it as sentience in the very simplest sense. Obviously, a multicelled body is made up of billions of sentient cells in that sense, as is the brain. Every neuron is sentient in that sense. What I'm arguing, however, is that if that same dynamical structure can actually be utilized and generated by the dynamics of their communication, then in a sense it's what I call teleodynamics of teleodynamics. It's made up of smaller teleodynamic. But the brain itself is also embedded in a body that has that structure as a whole. And so, in effect, it's being sentient of its own sentient foundation. And it's that second-order sentience that it creates this kind of almost liar's paradox of linkages where you, in a sense, Doug Hofstadter calls this a strange loop, in which you're experiencing your own dynamics of experience.
So you think that this second-order sentience is something qualitatively different than the sentience of the single
Qualitatively different, yes. That's what I would. That's claim.
So my question's for Catherine, and I was wondering if these positive emotions are sort of these motivator forces towards developing biology. How would you comment on psychopathy and corporate capitalism? And that seems to be a developing quality that we're striving for in our society. And do you think that as a whole, by paying attention to these things, we actually have the possibility to sort of switch that around? Or is that, I mean, how would you explain that or comment on that?
Big problems, right? I think the most important thing that we need to think about as a species is what we mean by capital. Of course, we have a monetary system that's based on, paperware, money, symbolic systems, and it's great for exchange. But if it ever becomes decoupled from the deeper values, when you look around, what's really running the show is emotional capital. We care about one another, we interact with one another, we barter, we trade, we cooperate, and if the banks collapsed tomorrow, we'd have each other. I'm not planning on a bomb shovel and a retreat with guns because of the zombies coming in. Nah, not gonna happen. We're cool, we're people.
Okay, thank you very much.